Is it possible that the truth of one statement necessarily implies the truth or falsity of another statement? The answer is yes, and that's what we're looking at today, and we've also covered in previous lessons. Welcome to Introductory Logic. We are in lesson 16, and we are talking about our third relationship between categorical statements called subcontrariety. Before we get into that, let's recap what we've already looked at. We have over here our relationships between categorical statements. We have discussed contradiction, which we're going to put on the square in a minute. Contrariety, same thing, we're going to do this in a minute. And today we're looking at subcontrariety. In future lessons, we're going to cover subimplication and superimplication. So, subcontrariety is what we're looking at today, and it is the opposite of contrariety. So if you remember contrariety was they both can be false, but they cannot both be true. Subcontrariety is the opposite, and it means that both statements can be true, but both statements cannot be false. So we're going to look at this, and we're going to get the information up on the square of opposition that we've covered already. As I've said in the past, in every lesson, I'm going to start with a blank square of opposition so we can fill it in, because this repetition helps us to memorize what we've already learned so far. So let's get to that first. First is our letters in the corners. We have A, E, I, O. And if any of this does not make sense, go back in previous lessons, and all of this is covered in those lessons back there. Now I'm going to put in my statements. All S R P. No S R P. Some S R P. Some S R not P. All right, now we're going to look at quantity and quality of these statements. How much of the subject are we talking about in each of these statements? So up at the top, we have all of the extension of our subject and none of the extension of our subject. So we are either including or excluding the entire extension of the subject. So up at the top, we have universal. The entire extension of the subject is discussed. Down here at the bottom, it's some are not. So down here, we're only looking at part of the extension of the subject. So this will be particular. So we've looked at the quantity. Now what about the quality? Quality is whether or not something is being affirmed or denied about the subject. So on the left side, we have all are and some are. So something is being affirmed about the subject. This is positive. On our right side, we have no are, some are not. So something is being denied about our subject. So the right side will be our negative. All right, now we will start getting into our relationships here. We're only going so far as what we've already covered. So the first thing we covered was contradiction. A and O contradict, and they do it back and forth, so they both contradict one another. It's not one way. And what contradiction means is one is true and one is false. So I'm going to write contradiction, and just remember it goes both ways. Contradiction. It goes this way and this way. And this one means one is true, one is false. Always. All right, next we have contrariety. Trying to keep my colors straight here. All right, so contrariety, we were dealing with our universal statements. Our universal statements are up at the top. So this is our contrariety. And contrariety means that they can both be false. Let's see. Both can be false. Whoops. Oh gosh. All right, cannot both be true. Hopefully you guys can see my tiny writing up there. All right, both can be false, both cannot be true. Because this makes sense, because you can, instead of all or none, it could just be some. There could be a third option down there. So both can be false, but they cannot both be true. So subcontrariety, remember sub means below. So subcontrariety is going to be below contrariety. Instead of universal, it's going to be talking about our particulars. So subcontrariety is dealing with I and O. And it is the opposite. So these both can be true. They both can be true, but they cannot both be false. Oops, cannot both be false. All right, so let's look at this. Is it true? Let's say if I were to say, replace this, I'm going to use this pink here. So to help us understand this, I'm going to put in an actual word. Let's say some birds are flyers. And we know that this is true. And then we could say some birds are not flyers. I think I have room here. Okay. All right. To recap, remember, when we're dealing with the square of opposition, all of our statements are going to talk about the same subject and the same predicate. So our subject class is birds in all of our statements, and if I were to translate all of those, bird would be in every subject up there. Flyer is our predicate class. So in every statement, flyers has to be in our predicate class. So some birds are flyers, some birds are not flyers. Well, we know for a fact that both of these are true. Some birds fly, think of an eagle. Some birds do not fly, think of a penguin. So very clearly, both of these statements can be true at the same time. However, let's test whether or not they can both be false. So they can both be true, but for the sake of our test, we're going to show that they cannot both be false. But first, I'm going to go up here and go ahead and change all of these to match our subject and predicate class. Birds, flyers, birds, flyers. All birds are flyers, no birds are flyers. Now, I'm going to use the rules of our relationships here to see what happens if I make one of these false. I'm going to say some birds are flyers, some birds are flyers are false. Let's just say this one is false. We're testing to see if this one can also be false. All right, again, we already know both of these are true, but we're showing how this works, okay? All right, so if we say this is false, using our rule for contradiction that we already know, if this statement is false, by contradiction, this one has to be true, because remember, one is true, one is false. We've said this one is false. By rule of contradiction, this one has to be true. We have not covered this next one that I'm going to say, but this would be super implication. If you know the universal is true, it necessarily implies that the particular below it is also true. So if this one is true, this one necessarily has to be true. Now let's look. This one was false, this one is true. So by rule of contradiction and super implication, this would have to be true. Let's do another one to see. I'm going to change the subject and I'm going to change the predicate to test it again. So this is how the square of opposition works, is you can see which statements you can see the truth value of statements based on where they are on this square of opposition, which is pretty cool. Let's instead do some students are intelligent and some students are not. So students, now, based on our rules, intelligent wouldn't actually work. It's an adjective. And if you remember, we have to have a noun in both our subject and our predicate. And so I'm actually, the common way to say it would be intelligent. I'm going to put intelligent person to keep our rule going that a standard categorical statement has to have a to be verb, which is are, and there has to be a noun in the subject and in the predicate. So intelligent is an adjective, so in order to make it following our rules, I'm going to add person in front of it. Or all students are intelligent. Actually, I should make it people because students is plural. All right, so this would be students as well. And I'm going to say I'm just going to say I over here. I don't have enough room and for time's sake. Now I'm going to do the same thing up here, but I'm actually going to say all S are I for students and intelligent people. Okay, so all of our statements have the same subject and the same predicate. So now we can look at the truth value and follow the rules of our square of opposition to determine the truth value or the falsity of other statements. So remember, we're testing down here whether or not, I need to erase this first, whether or not both of these can be false. We've already determined that they can both be true, but we're proving how they cannot both be false by our rules. So let's now make some students are not intelligent false. Let's say this one is false. Some students are not intelligent people. If we say this one is false, by rule of contradiction up here, that this one would have to be true. Now, by rule of implication, which we haven't covered yet, if the universal is true, it implies the truth of the one below it. So this one would have to be true. So there again, when this one, if one of them is false, the other one will be true by the rules of contradiction and implication. So that's pretty cool. And honestly, we could go a step further. By rule of contradiction, we could go back up here. If this is true, this one would have to be false. So actually, we could even put in the truth value of that one too by the same contradiction rule. So that is how an example of how you can use the square of opposition to determine the truth value of other statements once you know the truth value of one, or if you're testing it like we just did. So this is it in action. So it's pretty cool when you can start to see how it works and why. And actually, the more you do things like this, you actually can start memorizing the rules too. Like the one is true, one is false. Both can be false, but they both cannot be true. Both can be true, they both cannot be false. And as you put this in more and more, it'll start clicking and it becomes easier and easier, and it's just fun. It's like puzzle pieces, like I've said. It's just puzzle pieces, figuring out where they go and how they're used. So this has been it for this lesson of subcontrariety. In the next lessons, we will look at superimplication and subimplication. You'll have a good day.